Hi, my name is Dave McKendry, and I'm Senior Fellow with the Canadian Electricity Association. And today on the Future is Now series, we're chatting about an innovative project from Elexicon Energy. I'd like to welcome Falguni Shah and Rajiv Varma, who are going to tell us a little bit more about this exciting project. And to get things started, we've got a couple of questions for you both. And Falguni, could you just tell us a little bit, please, about how this project became a priority for Elexicon Energy?
Yeah, of course. Thanks. My name is Falguni Shah, and I'm Vice President of Technology and Innovation at Elexicon Energy. This project is basically a funding project from LDC Tomorrow Fund, managed by Mearie, and we are working with University of Western Ontario in a joint committee. This project is basically the high penetration of renewable generation in distribution system has introduced more uncertainties and a lot of technical challenges from the operations side in the distribution system. And due to intermittent nature of this renewable generation, it is essential to develop some sort of a technique so that we can manage and balance the voltage load and voltage profile. The optimum power distribution is also help distribution losses, and it will provide adequate power capacity and availability to the customers. The project is very important for Elexicon Energy because it is using existing asset, the inverters installed at our customers, and utilizing their unused capacity to provide system benefits, which includes power quality, energy savings, and eventually it will help reduction in energy bills to our customers.
Well, thanks very much for that overview. You mentioned the words power quality. What type of challenges are you seeing with power quality, and what's the impact on the grid?
Yeah, so the power quality is play a very important role. When the interconnection of renewable energy comes in place, you cannot interconnect those without power electronics in place. When I say power electronics, that means basically the inverter, which is a major power electronics device. And with those use of power electronics, there is a voltage imbalance issue, voltage sag and swell, harmonics, real and reactive power become sometimes issue as well. So those are the power quality issue we experience by having a more renewable energy, the power electronics based connection to the grid. And I think Dr. Varma
That's great.
can explain more in detail if he wants to say something.
Please.
Sure. Thank you, Falguni. I just want to continue on what Falguni has mentioned. I think the biggest challenge for the power quality challenge, as I see, is the integration of renewables. The solar is growing at a phenomenal rate across the world. And one of the biggest challenges in integrating solar is the rise in voltages. The moment, because of the real power that they generate, the voltage starts to rise. So that's the most significant challenge, the power quality challenge that comes because of integration. And there is a limit on how many solars you can integrate on a line, because the voltage will start violating the utility limits. So the challenge is that how do we control the voltages by the solar systems themselves? So solar systems, they create a problem. But now with smart inverters, the solar inverters can solve their own problem that they created, plus solve many other challenges which are created by other things in the system. So this is where our project starts.
So Rajiv, on that line of discussion, how does the inverter help to reduce line loss issues and conservation voltage reduction impact on Ontario customers?
Perfect, thank you. So by the way, just to mention that line losses in Ontario at the moment, you'd be surprised that it's only about 3 to 4%. But if you look at the total demand in Ontario, 3 to 4% are enough to supply half a million people. And imagine this is the power, power going to 500,000 people is just getting evaporated into the free space. So even if you make a small dent in that, that's going to be very much a big saving for powering homes of different people, especially in remote communities who have a big problem. And the second thing is during the peak time, we have the peak power demand rises in the evening and also during the afternoons during air conditioning loads. So there is a challenge of is there a way how we can reduce that peak demand, do the peak shaving, and if we can reduce the line losses. So what we are doing here in this project is we have developed a patented technology of using solar farm in the night. In the night when they are supposed
Which
to.
is not intuitive, but wow, that's really cool.
Yeah. So the thing is, solar farms are absolutely idle. But the important thing to remember here is that the inverter and the entire asset is available, which is sleeping. So we developed a technology of transforming the internal of the inverter into a dynamic reactive power compensator by which we can control the voltages in the night as well as during the daytime. And we have applied not just to the solar inverters, but also to the battery energy storage systems, which are actually in existence in Falguni's Elexicon network. And what we are trying to do is, just to summarize, reducing line losses means that you must reduce the differences in voltages across 2 points, because the lesser the difference, you have smaller current and consequently smaller I square R. And the second thing is, for conservation voltage reduction, we have to reduce the voltage a tiny bit by 1 to 2%, and then we can have very large amount of saving. And all this voltage control can be affected by the reactive power, which is available from the solar farms in the night, as well as early morning, late afternoon, and also from battery energy storage systems when they are not charging or discharging. So as Falguni mentioned, that we are using existing resources, unutilized resources, for bringing in very nice benefits, which are for the utility customers, because if we reduce the line losses, right now the losses are being passed on to customers. So if we are successful, and we have done some studies to show that effectively, it impacts the customers' bills are hopefully will go down. And also because of less heating in the lines, their lifespan gets increased. So these are the things that we are immediately thinking of. In fact, we are working on right now.
Some great benefits. Thanks very much, Rajiv.
Thank you.
Falguni, back to you. Where do you see the use of intermittent renewables going over the course of the next 10 to 20 years?
Thank you. Since this intermittent renewables, we don't have any control. So we don't know when wind is going to blow or when sun is going to shine. The best strategy to cope with this is energy storage, either underground or battery storage. And since we all are striving towards this reduction in carbon footprint, and energy users are also more aware and they wanted to be participant in saving the environment, I can see that more and more customers wanted to have their own energy usage and energy generation. And because of this, I am thinking that the more users will get the technology will be available at more affordable rates as well. So down the road, more customer will have the own generation at their local location, as well as they want to be participate in the market and they want to become a prosumer. So they will be a producer as well as a consumer both. So that new term nowadays more popular is prosumer. So that's what I see down the road, that customer will be more engaged. They wanted to have their own generation as well as they want to be a market participant as well.
Great, thank you very much. Rajiv, same question to you. Where do you see intermittent renewables going in the next 10 to 20 years?
Actually, they are going, there's a phenomenal increase, and the problem of intermittency, as Falguni mentioned, that it is easily solvable through battery energy storage systems and other energy storage systems. But intermittent sources are here to stay. In fact, according to an International Energy Association report, by 2050, about 38% of global electricity is going to come from solar itself. And almost about 30% will come from wind. So almost you can say about 70% is coming from these intermittent resources. So we have come to live with that. And the technologies have evolved so that the intermittency can be smoothened out. When you have intermittency at a large scale on different solar farms, for example, they tend to balance out because different shading effects happen at different times. Similarly with wind. And also there are power electronic controls that have been developed so that you can smoothen out the power from a solar plant. In fact, a 300 megawatt solar plant in California does the same thing. So they can smoothen out their power system, the output, just by the control of inverters. So that is part one. But to couple that with energy storage system, you have the best of the worlds. You can store the energy, you can smoothen out, and you can use it when sun is not there or when the wind is not there. So I don't see intermittency used to be a problem. I mean, there was a big worry, but there are technologies available, both from inverters as well as energy storage, by which this is getting solved. And in fact, it's going to grow even further, as I mentioned. Okay.
Final question to you both, and this is just a challenge. What's the one word you would each use to describe electricity? Falguni, we'll start with you.
This is excellent question, and I cannot think life without electricity. So one word is to describe electricity is life.
Life. Thank you very much. And Rajiv, one word. How would you describe electricity?
Now, I would say electricity in one word is power. And power to learn, power to gain knowledge, because when we have power, we have all the computers, we have the whole web, and we have all the learning education system. So power to learn, power to grow, power to have a more comfortable life with all the, we have life, we are so much dependent on electricity systems, and power to have a safe life, because all our medical systems are relying on power systems, on electricity. So electricity in one word is power for learning, for having a safe life, for having a quality life, and for our growth.
Both excellent answers to that simple question. So thank you both for joining us on the Canadian Electricity Association's the Future is Now series. We appreciate your time with us today. Thank you both.
Well, thank you so much. It was wonderful talking to you, and thank you for taking the time for having this interview.
And thank you for giving us opportunity to talk to you and part of the CEA innovation. Thank you.
Thank you, Falguni.